Mankind first started utilizing carbon for energy since the dawn of the Industrial Revolution in the 1760s. With the use of carbon to fuel growing industries came the increased emission of carbon dioxide, methane, and nitrous oxide, among other fluorinated gases. More commonly known as greenhouse gases, they have been slowly accumulating in our atmosphere, and this trend shows no signs of slowing down. As more and more of these gases accumulate in our atmosphere, they trap the heat coming from the sun. Known as the runaway greenhouse effect, this slowly increases the global average temperature. An increase in global temperature can be associated with the melting of the ice caps, the rise in sea levels, and the gradual deterioration of the quality of air in congested cities. Climate scientists agree. If we do not take serious steps to reduce our greenhouse gas emissions by 2020, it will be too late to save the planet we call home. To combat the threats these emissions pose in the form of global warming, many countries and even individual companies, colleges, universities, and citizens are taking steps to reduce their carbon emissions. Germany specifically has engineered a policy known as the Energiewende to serve as a model for carbon-dependent nations and to ensure that their citizens and their children will not have to face the problems associated with climate change. One of the first steps Germany took to do this was to figure out how to measure their greenhouse gas emissions. But how can we tell how much we are emitting? Greenhouse gas emissions are measured using a technique called carbon footprinting. A carbon footprint is the total emissions caused by an individual, organization, country, or other entity expressed as a carbon dioxide equivalent. Emissions of methane and nitrous oxide are converted into carbon dioxide equivalents using conversion factors based on how bad each gas is for the environment. Greenhouse gas emissions are evaluated using three categories, known as scopes. Scope 1 is associated with the direct emission of greenhouse gases through the burning and use of fossil fuels. Scope 2 comes from more indirect sources, such as the emissions associated with purchased electricity. Scope 3 is made up of other indirect sources of emissions, like the disposal of waste and transportation. To calculate greenhouse gas emissions, the first step is to gather data pertaining to each of the three scopes. Each scope gives us information such as how many British thermal units of carbon, how many kilowatt hours of electricity, or how many miles of transportation are associated with the college. This data is then converted into kilograms of carbon dioxide, kilograms of nitrous oxide, and kilograms of methane using nationally published emission conversion factors. The kilograms, nitrous oxide, and methane are converted into kilograms of carbon dioxide equivalent. Finally, the three amounts are added together and converted into metric tons of carbon dioxide equivalent. When applied to Vassar College, this methodology yields the following chart. Vassar's carbon emissions have gradually diminished from 2006 to 2012 due to actions such as agreements with Gravity Renewables to purchase hydropower and with BQ Energy to build solar panels. In 2016, Vassar passed a climate action plan in which the school established the goal of achieving carbon neutrality by 2030. In this publication, Vassar laid out a plan to reach this goal, detailing the specific actions that will be taken to reduce emissions. However, the plan leaves 26.5% of emissions to be determined. This inspired us to take a look closer at Vassar's greenhouse gas emissions and to think about what changes can be made. But how can Vassar reduce this final 26.5%? The suggestions that our project has led us to include renovating buildings to passive house building standards in order to avoid unnecessary heat loss, purchase renewable energy to the extent possible, utilize LED technology, create a campus-wide discussion about our responsibility to fight climate change in order to encourage behavior changes in electricity and heat consumption, and install motion sensors on lights in academic buildings so that lights will automatically turn off when air is not in use. Implementing these changes will bolster the effort introducing the Climate Action Plan along with other initiatives to make this a greener campus, and will ultimately bring us closer to achieving carbon neutrality by 2030.